All right, let's do our pre-calculus review. I'm going to do this in sections, so you'll see I'm going to post the different videos, mostly because I just don't want them to be too long, and it'll take longer for them to upload. Okay, starting with number 1. 1, 2, 3, 4. Yes, the first 4 are our trig questions. Everybody's favorite, including mine. Number 1, this is the X, Y, R, SOHCAHTOA, Pythagorean theorem stuff. Okay, so you're going to need those X, Y, R things. I'm going to come down here so I can write. So again, I'm going to just do sine, cosine, and tangent real quick. If you remember, cosine is X over R, sine is Y over R, and tangent is Y over X. And of course, we use the Pythagorean theorem to help us find the value of R. Right, now I know in our problem they give us cotangent and are asked for cosecant, but this is where we remember which reciprocal goes with which, right? So let's start with what they give us. They do tell us that cotangent, yes, cotangent is a negative square root of 35. Okay, little disclaimer, as I mentioned in class, lots of ways to do this differently. This is just, to me, the easiest way because it utilizes stuff we already know. So if I write this as a fraction, all right, that means that since cotangent is the reciprocal of tangent, this is X over Y, right? So again, we know that X is this, Y is this, for all intents and purposes, and then we're gonna look for cosecant. Now we know that cosecant, because that's what it's asking us for, is the reciprocal of sine. So R over Y is what I'm looking for. And I know that Y is 1. I just have to find R, so that's where I'm going to use the Pythagorean theorem, right? So I get the square root of 35 squared plus 1 squared. Notice I left off that negative. We've had that discussion Y as to about 50 times. So please just leave off the negative. That's one less mistake you're going to make in the calculator. You know you're going to get a positive. And I do on this one, right? I get 36 equals R squared, or 6 is the value of R. So now I have Y, now I have R, now I have to decide which quadrant it is in. That's really important, which is why they give us that last little tidbit of information. I know that's probably a crooked line. I'm holding my iPad sideways. Sorry, guys. We know in the quadrants, right? Plus, plus, minus, plus. How many times have we written this down this year? Plus, minus. And we know that this is cosine and this is sine, right? And we know that tangent is sine over cosine. All right, did that lots and lots and lots of times. So in the problem, it says that cosine is negative. So cosine is negative here, right? And cosine is negative here. So it's one of those two. However, we can see that the cotangent they give us is a negative, right? They tell us that cotangent is a negative 35. Well, cotangent is the reciprocal of tangent, which just means I'm going to be dividing cosine by sine, which means that it has to be this one. Because if I divide a positive by a negative or a negative divided by a positive, either way, I will be getting a negative answer, or cotangent is a negative. All right, so since we've decided that, okay, so again, we know cosecant is R over Y, or 6 over 1. We're trying just to decide now if that's positive or negative. It's going to be a positive because cosecant is the reciprocal of sine. Sine in this quadrant is a positive number. The reciprocal of a positive is still a positive. So my answer is positive 6 over 1, or just 6. Just 6. Okay, so you guys have had me for enough years since you know that I make mistakes. So if you have your previous review, number 2 is wrong on the previous review because I mistakenly said that cotangent was sine over cosine. And I think I was doing it in a hurry and made a boo-boo. So here you go. Number 2, the correct way. Now, okay, so before I get started, oops, let's not do that. I'll just put that there for a second if you want to copy those. So those are the fundamental trig identities that we went over, the ones in the blue box. We'll do the other ones in a minute. So these are the ones you need to know. And again, it's important that you know which reciprocal goes with which one. And I, again, mistakenly said that in our review that cotangent was sine over cosine. Obviously, you can see that's not a thing. So pause, copy, whatever you need to do with that blue box. There you go. Okay, so let's come back up to our problem. I'm asked to reduce cosecant times cotangent over secant. Yes. So what I like to do is like to write everything in terms of sine and cosine. Cosecant is the reciprocal of sine. Cotangent is correctly cosine over sine. And secant is the reciprocal of cosine. Okay. So I just went and wrote everything in terms of sine and cosine. And what that does is that gives us something for us to actually do. Now I can multiply and divide and all that fun stuff. So in the numerator, that's going to give us cosine over sine squared. And in the denominator, I still have the 1 over cosine. So I just multiplied those top two fractions. Now that I am dividing a fraction by a fraction, I'm going to simplify that. So the numerator is going to stay cosine over sine squared. Then I'm going to multiply by the reciprocal of the bottom, which is cosine over 1. When I multiply those together, that gives me cosine squared over sine squared. And as I have mentioned like 3 times by now, I know that cosine over sine is cotangent, which would follow that means that if it's squared, it's cotangent squared. So that is actually the correct answer for number 2, cotangent squared. There we go, cotangent squared. Okay. Hey, we're finding the 2 solutions to the equation. I did tell you that you could use a circle if you have it. So if you have it, you can use it. If not, here we go. Now you can also use your calculator. If you're using your calculator, be sure that your calculator is in radians. That's very important. I happen to not have a calculator in... Do I have a calculator? I don't know. Oh, look, I do have a calculator. And when I put it in radians, oh, I'm already in radians, fantabulous. So what I'm typing in to get my first answer, because look, you need 2 solutions, is I'm going to do the inverse cosine of negative 1/2, right? So I'm going to do the inverse cosine of a negative 1/2. And what that will do is that will give me one of my answers, which happens to be 2 pi over 3. Now, it does give me also a decimal, which you can convert that. So I know that 2 pi over 3 is one of my 2 answers, right? I just need the second one. So going back to, if you have your circle, or if you're familiar with this lovely thing that we've written down a bazillion and a half times, I know that cosine is negative here, right? Negative and positive. And that's, as a matter of fact, that's exactly where 2 pi over 3 is, right? It's in that quadrant. Cosine is also negative down here. So I need the angle that's going to be in quadrant 3 down here that's equivalent, that has the same reference angle as 2 pi over 3. So you have a couple of options. Again, one, if you have your circle, your answer's right there. Cosine is your x value, negative 1/2. Other option is to just count, right? So we all know that I can't count. So, right? So this is pi, right? And I would just be adding, well, actually, I don't need that middle line, do I? Boop. Oh, no. I hate this thing. There we go. Negative, negative. Right, so if you're looking at your beautiful circle, that's, let's see, that's 6, 6, 7 pi over 6, 8 pi over 6. So that's going to be 4 pi over 3. That's that one. So 4 pi over 3 is going to be the other angle. Just use that circle. I'm telling you, it comes in super duper handy. Okay, so that's the answer to number 3. Number 4, sum and difference identities. So in case you didn't see it a minute ago, There are some difference identities. I will not be giving you a tangent one, so don't worry about copying those unless you're just, really want to write some pretty stuff down. But I would definitely jot down sines and cosines and pay attention to where your positives and negatives are. So this one is obviously a cosine. It's the cosine of 75. Cosine of 75 is not on our circle, so I will have to think of two of the angles that are on my circle that either add up or subtract to 75. Of course, I'm going to go with the two easiest ones, right? 30 and 45. So I'm going to come back up here. And again, this is number 4. Cosine of 75. So I'm really doing the cosine of, and it doesn't matter the order that you're putting them in since you're doing addition, 30 degrees plus 45 degrees. And I'm going to plug that right into my formula. Again, you're going to use, so notice how this one, since I'm adding, I will be subtracting here. And notice the use of 2 consecutive sines and cosines. So that would be the equivalent of the cosine of 30 times the cosine of 45 minus the sine of 30 times the sine of 45. Okay, I have to see this step, okay, because you can all day long type in the cosine of 75 and it's going to give you the answer. And I don't want to know if your calculator can do it. I want to know if you can do it. So I need to see that. I'm in the middle of changing my calculator to degree mode. Okay, there we go. Lovely. And the reason I'm doing that is mostly because I'm being a little lazy. I shouldn't do that. If you do decide to use your calculator to find the cosines and sines of 30 and 45, make sure you're in the right mode. Those are the degrees. I'm going to actually use my hand. Alright, so the cosine of 30 is the square root of 3 over 2. The cosine of 45 is the square root of 2 over 2 minus. The sine of 30 is a half. And the sine of 45 is the square root of 2 over 2. We talked about how in class, whenever you reduce and multiply this, you get the square root of 6 over 4 minus the square root of 2 over 4. And how that is 5,000% a perfectly acceptable answer because there's really nothing mathematically you can do about that. Now, if you do decide to write it as a single fraction, that's quite all right as well. It would just be the square root of 6 minus the square root of 2 over 4. So that is the answer to number 4, the square root of 6. The square root of 6 minus the square root of 2 over 4. Got to see that work though. Okay, so that's the first section. That's the trig section. Okay, let's look at the next 4 problems. These are our polar numbers in complex form. Yay, math. You guys are going to miss me. Nobody would ever say yay math except for me. Okay, so number 10, you're writing it in a plus b I form, which is just a fancy way of saying I've got to do the distributive property. The first thing I do notice, however, is that my angles are in radians. So I'm going to go right to my calculating device. Whoops. And I'm going to change my mode to radians. So let me do that. Unfortunately, more than just one button on mine. Got to hit like 7 of them and I always hit them in the wrong order. Here we go. Okay, so the first thing I'm going to do is I'm going to, wrong button, multiply 3 times the cosine of pi over 3. So 3 times cosine of pi over 3 gives me 3 halves or 1 1/2. We all know how I like fractions, so I'll be sticking with the 3 halves. Then I need to do 3 times the sine of pi over 3. And remember that I is the imaginary number I. So we're going to make sure and leave that alone. I'm just going to stick it on there in just a second. So I'm going to do 3 times the sine of pi over 3, which is going to give me some really not nice decimal. Or preferably, I'm going to leave it in root form. So plus 3 on the square root of 3 over 2i. So that is the standard form of that polar number. Okay, number 11 and 12, that's the product and quotient rules. These are really, really easy. Remember, what you're going to do here is you're going to actually take the R values in the front, in this case the 2 and the 25, and you will multiply those two numbers together. That's pretty straightforward because 2 times 25 is 50. Then what you're going to do is you're going to take the two angles, negative 80 degrees and 200 degrees, and you're going to add them because you are finding the product, right? Product add goes together. So if I add those two together, that of course is going to give me what, 120 degrees. So it's going to be cosine of 120 plus I sine 120. I'm totally running out of room here, but that is, they want to make sure and leave our answer in trig form. So I'm going to leave it in trig form. That's number 11. Multiply now. Of course, since we're doing the quotient on number 12, right, we're doing the quotient, that's going to be exactly opposite. I need to divide 5 over 3. So I'm going to leave it as 5 over 3 because I do not like repeating decimals. This time I will be subtracting 45 minus 225, which gives me negative 180. Again, I'm subtracting my two angles. Make sure you do the top number minus the bottom number. They need to go in the correct order. So it would be negative 180 plus I sine, again, totally running out of room, negative 180. All right, so that's 11 and 12. And then De Moivre's theorem. We love De Moivre. He was super duper helpful. De Moivre's theorem helped us raise a polar number to a power. Now be careful here, we do have to write our answer in a plus bi form. So I'm going to go ahead and do De Moivre's rule, which means it's 5 to the third power. So again, you're going to take this R value and actually do to it what we're supposed to do. So 5 to the third power. And then you're going to multiply your angle times the power. Of course, that's 270. So I'm going to do the cosine of 270 plus I sine 270. All right, so that's the polar form. I need the standard form. Now, if you're choosing to use your calculator to help you with this, because maybe it's not going to be as nice, you need to make sure to change it back to degrees, because the last time we used our calculator back in number 10, it was in radians. Please pay attention to that. You will get the wrong answer. 5 to the third power is 125. I'm fairly certain. You guys know me. I'm going to check my work because today has been a day. All right, okay, 125. Cosine, that's what it's 270 is 90. Cosine is top. So this is 0. And this is negative 1. Right, so if I were to distribute to that, right, if I were to distribute that, kind of like we did back in number 10, obviously 125 times 0 goes away. And then 125 times negative 1i would be negative 125i. So that is standard form for number 13. And the polar numbers. Alrighty, last one. Starting with the number 14, we're finding the derivative of the function at the specified point. So we're going to use that power rule and the sum rule and the constant rule. If you remember, the power rule is if I have x to the nth and I want to find the derivative, it's just n times x to the n minus 1 power, right? So that's exactly what I'm doing with that x squared. Now this x squared happens to not have anything in front of it. Really, there's a 1. So I'm just going to bring that 2 down, and that's going to become 2 to x to the first power, right? Or just 2x. Now with the 7, same thing works there, right? 7x, really, we know there's a 1 there, so whenever I bring it down, that's just 7. And whenever I do 1 minus 1, that's to the 0 power, or just a 7. And as we talked about, that the constant rule, whenever I go to find the derivative of anything that's just a number, it's a 0. So that means the derivative of f of x is 2x plus 7. Now, that's not what they asked for. They actually asked me for what is the derivative at 0. So I'm just going to go and take and plug that in, because now I know what the derivative is. I can plug in any number that I want. 2 times 0 plus 7, of course, is just 7. So I like that rule. That's really nice. Beautiful, easy, fantabulous math. And then the last one, we're finding the area under a curve. Here they're asking us to use 5 sub-intervals. So I'm just going to take my straight edge and I'm going to the best of my ability, draw crooked lines because we know that's all that I'm good at. Here we go. 4, 5. So there are my 5 sub-intervals. And since this is not on graph paper, I'm going to make my life easier and go this way as well. Now, we talked about we are just estimating here, right? Now, technically 4, I mean, I would go like right here or something, like that's, you know, a little tiny. And we were just estimating, right? Estimate the area in the curve. Now, I do expect a close estimate, but like, I'm just going to count this whole squares first, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Might as well count that one as 14. Maybe 15 and 16, right? Because we do have a little corner here and a slice there. So I would say approximately 16. Actually, why don't I just write that where I need to write it? 16 would be the approximate area under the curve. All right, guys. That's it. That's your exam. Okay, the next section is color curve. It's going to be real short because it's only 2 questions. Number 8, we're asked to draw a graph of the rose curve, and we're going to pretend that I can actually draw. So the rose curve, remember, is determined by we need the number of petals, right? So we're looking at the number in front of theta. If it's odd, that's how many petals it has. So this one happens to have 3 petals. If it's even, you're going to multiply that number times 2. So if it's 2, you'd have 4. If it's 4, you'd have 8. If it's 6, you'd have 12, whatever. Remember sine, that's our top bottom function, right? Because it's our y value. And the 2 just means that's the length of the petal. So obviously I'm not going to be super picky, we're just sketching. So this one has 3 petals. So I'm going to start with the one that I know that's on the bottom. And I'm just going to, for sketching's sake, going to say, okay, that's technically -2 since it's down. Okay, so there's my first really beautiful petal right there. So remember, these have to be symmetrical. So my other 2 petals have to be in a space. And we've got one that'll be in the positive part here. All right, it's going to be in quadrant 1. And the other one would be in quadrant, whatever this one is, 2. Okay, my brain just turned off. So that's it. Sketching number 8. Number 9 is a cardioid, right? A lemma curve. It's the one that kind of, you know, it's supposed to look like a heart. It's just flat. And we wrote down, remember, if it's sine, it's going to be on the top or the bottom. If it's cosine, it's going to be on the right or the left. Okay, so you're going to look at, see what side of the graph it's on. Of course, top and right are going to be plus signs, bottom and left are going to be minus signs, and if it's a cardioid like this one, remember that your A and B value have to be equal. So right off the bat, I know that it cannot be A, and then it cannot be C because the A and B values are not equal, right? 3, 2, 1, 3. And obviously this is a sine win, that's the only other 2 options we're given. And we can see that it's on the bottom, right? And since it's on the bottom, we know that it needs to be a minus sign in between. So B is the correct answer here. So again, jot down what you need to jot down, but those were the polar graphs. So here we go. Part number 2, we're going to look at these 3 vector elements. These are pretty easy. Magnitude. Remember, magnitude is just the Pythagorean theorem, right? The magnitude, we always wrote it like this, the magnitude. And it's just the Pythagorean theorem, just like the x, y, r squared. So it's going to be the square root of -5 squared plus 14 squared. And again, we discussed, please feel free to leave off those negatives. So 5 squared plus 14 squared is 221, which does not reduce nicely. So that means you are more than welcome to leave the solution as the square root of 221. If you wish to round it, you're welcome to do that. It doesn't give directions on rounding the magnitude, but if you do, you get 14.9. that is the magnitude, that's the length of that vector. Now, the direction angle is just SOHCAHTOA, right? It's just the tangent. It's going to be the easiest way to do this one. Tangent, as we just wrote down just a minute ago, is y over x, right? So if it's y over x, that's going to be a negative 14 over a negative 5, which of course is going to be a positive. Making sure it is in degrees, because if you'll look very carefully in the directions, it says this needs to be in degrees. And I am in degrees. Okay, so I'm good. So this one's going to give me a not nice answer. So the inverse tangent of 14 over 5 is 70.3. So I asked for that specifically, rounded to the nearest tenth. So the angle for that one would be 70.3 degrees. Remember, you're using the inverse tangent, right? That's the function you're using in your calculator. Okay, so that's number 5. Number 6 is the dot product. We love the dot product. It's so easy. So in the dot product, remember, you're going to take these a values and you're going to multiply them. And then you're going to take the b values and then you're going to multiply them. And then you're going to find the sum. So that's pretty easy. So I'm going to do 6 times 2, the pink ones, plus, always plus, the green ones, 2 times 4. So 12 plus 8 is 20. We love the dot product. Comes in handy dandy because we're fixing to have to use it in problem number 7. Problem number 7, we're finding the angle between the two vectors. And so the formula for that, in case you did not write it down, it is the dot product of the two vectors over the product of the two magnitudes. Okay, I'm gonna, since I have plenty of room right here, I'm gonna utilize this space. I like to do mine separately because, as I've mentioned about 100 times, I will definitely get lost. So let's start with the dot product. The dot product on this one, unfortunately, is not very nice. Again, we're multiplying the two a values, we're multiplying the two b values, and then we're going to add them together. So here's the thing. I have a positive 1 times a negative 1. Now that's the numbers in front of I. And then I have the square root of 7 times 8. So the only thing you can do with this really is just make it look as pretty as possible. Negative 1 plus 8 times the square root of 7. 7. I said 7, and there we go, 7. I highly suggest to not make that a decimal. It will make your life harder. We're going to make our calculator do the work for us. Now I'm going to need the magnitude of u. The magnitude of u, again, is just the Pythagorean theorem. That's going to be 1 squared plus the square root of 7 squared. So that's going to be the square root of 1 plus 7, which of course is the square root of 8. Again, I know that reduces, but I don't reduce it because my calculator is fixing to help me out with it. And then finally, I'm going to do the magnitude of v. One more time, the Pythagorean theorem. Listen, I definitely know that's a negative 1, but I'm using it in the Pythagorean theorem. So let's just make that a positive 1 squared so we don't mess ourselves up. That, of course, is going to be the square root of 65. So what I did, again, was I did each one of them separately. Right? I did that. All right, that's this thing. And then I did this. Here's this thing. And then I did this thing, right? I did them all separately. So here's what I'm typing in my calculating device because, again, we are to the 10th of a degree. Right, so again, making sure my calculator is in degree mode. I'm finding the angle that those two vectors make. So here we go. I have to do the inverse cosine because I am looking for an angle. The dot product was negative 1 plus 8 on the square root of 7. The magnitude of u is the square root of 8, and then times the square root of 65 for the magnitude of v. And that's what I'm going to be typing into my calculator, y'all. I'm sorry, my 5s look weird. So inverse cosine. And we're doing negative 1 plus 8 on the square root of 7. And then my denominator, I'm going to do the square root of 8 times the square root of 65. And I get a very lovely, we're rounding to the nearest tenth, so it would be 27.8 degrees. 27. So for 7, the angle is 27.8 degrees. Right, so that is our vector section.